Hi guys, welcome back to my channel. Today we're going to look at 0x08 C Recursion. Alright, and as usual, I'm going to use Replit to write these codes, and I'm going to call it recursion. Alright, so firstly, what is recursion? Let's check on Google. What is recursion in C? Okay, here recursion is a process that occurs when a function calls a copy to solve a smaller problem. Any function that calls itself is called the recursive functions, and calls to this function are called recursive calls. Okay, take for instance, when you were dealing with shell navigation, shell basics, shell expansions, and the rest of them. There is something you normally do when you want to delete a folder that has files inside. You use rm minus r and then the folder name, right? We normally know that the R minus R flag stands for what? Recursion. What does that mean? Instead of you to open the file or the folder and then delete those files one after the other, you use minus R so that it will recursively delete those files by itself by calling the function recursively. So that's exactly what we want to do right here in this very program. But let's understand with some concept. Let's understand the foundation of what recursion really means. Now, it works just like a loop. It works just like a loop. All right, so let's take, for instance, you want to write something to the standard output depending on the string that is given in the program. So we have something like this, char, and then we can say name. You want to pass engine tech. For you to print this using a put char, of course, you need to loop through it. So I can say for int I equal to 0, the name of I, the name I plus plus. Okay, and then here I'm gonna say putcha name of I. Okay, so if I run this program, you can see engine tech printed on the screen. Of course, you know how to do this already. Now we can use recursion function to actually do the same thing. Okay, so let me write a function to do that. Let's come here and then declare our function. Let me call it char, and then I'm gonna call it print me as the function name. Okay, and then character pointing to ch. All right, now in recursion, you have to specify where the value is going to start from, and then you have to call the function repeatedly to do that thing till the end. And basically what you use in recursion is the if statement. Basically, if is basically attributed to recursion. So the first thing you want to do is to check if the value entered is null. That means nothing is entered at all. So I can say something like, if the value of ch is not equal to null, then you got to do something. Then what you need to do is first, you got to print the first index, which is the ch of 0. So you can say putcha, first you got to print ch of index 0. And then when you're done with that, you have to take the next value, the next index recursively. So I'm going to call the function name. So I'm going to say print me. And what you're going to print is ch plus 1. That means move to the next content and print. Move to the next content and print. Okay, so having done that, I will have to return 0 here. All right, so in this program, instead of using the for loop, I will simply call that function. So I will say print me, print underscore me, and then I'm gonna pass the name. Okay, so let's run this and see what happens. Now you can see we have engine tech printed on the screen. All right, So this is recursion. What you've just done here is actually recursion. You're trying to call back the function to print those values one after the other. That is the work of recursion. And sometimes recursion actually makes your work simple. It makes your code simple. All right. Now take for instance, if you want to reverse this string starting from H, C to the end of E, normally for you to use a for loop, you have to count the number of characters in the string. Then from there you can reverse it by using the last string or the last character as the beginning of your index through 0. But using recursion, you can simply interchange the position of your putchar and your recursion function. Then if I run this program, you will see that it reverses. So this actually makes your works more easy than the other way around using the for loop. However, you can choose to use a pointer here, a pointer ch. It's still gonna give you the same result. So be it you are using the first index or using the pointer, it will give you the same result. Okay. Since the pointer actually points the first index of your array, so it's still going to work. All right. Now let me introduce you to something that it's essential. I believe you should have an idea of this. Now sometimes if you go online or someone's GitHub and probably don't understand what the code really means, you can use the chat GPT to get the answer to understand what the code means. What you simply do is, for instance, to copy this code. Let me copy it. Then open your chat.openai, just like what I got here. Then when you open in the bar, you can write something like explain the code below. All right, then paste that code here, run. Now you can see the AI will take time to explain the code in details, one after the other, line by line. So if probably you did not understand the code, maybe what I explained is not really making sense to you, you can come over here and then try to read over for the program to explain the context one after the other for you. If it does not really give you what you want, you can simply reframe your context of question. Maybe explain the below code in lines. Okay, then you paste the code, run. It is going to take time to explain that code line by line. You can see what is happening. It's taking the code line, explain it in line, take the next code, explain it in line, take the next code, explain what it means. This is going to help you for a beginner to understand deeply what the code you copy or what the code you're trying to learn actually means. Okay, so that's that. Now let me try to give you another insight of what this recursion can actually do. Now take for instance, you have something like this. Let me just remove this. Now I have something like this integer num printf enter a number. All right, /t scanf %d address of number. Okay, now what I'm trying to do is that if you enter a value like 3, it's gonna add 1 plus 2, that's 3, plus 3, that's 6. So any number you give is gonna add that number serially to the last number you in. So what you should do after this is for integer I equals to 0, I less than or equal to num, then I plus plus. All right. So in here I can declare another variable called sum. Okay. So in here sum we'll have to add sum plus equal to I. And then let me initialize my sum to be equal to 0. Hence printf percentage D, let's have a new line here, and then sum. Okay, so let's run that. It's asking me to enter a value, so I'm going to enter 3. I'm expecting 6 as an answer, so we got 6. That means it's summing up the values in a difference of 1s. 1 plus 2 plus 3. So if probably I run this program again and put something like 4, it's supposed to give me 10. All right. So this is still a recursive kind of function, but I'm using a for loop to write this. You can use a recursion to actually do the same thing. So let's try to do that here too. I'm gonna first declare my function. So I'm gonna write integer, let's say sum, and then I'm gonna pass. I just need one argument. So I can say integer. Let me just use x. All right. And then the first thing you need to do is to pick your start value. Of course, if I enter 1, you don't need to add anything because 1 is already 1. So I'm gonna say if your x is equal to 1, then there is no point doing anything, just return 1. Okay. But however, if it is more than 1, else if x is greater than 1, that means you need to do something. All right. So what you will need to do is to return the value of x added to the recursive function sum into brackets x minus 1. Okay, now let's see if that works first before I explain the code. Let's return 0 here. So in here, I'm going to remove this. Then here, I'm going to pass sum in brackets num. Okay. Right, and I got to remove this to avoid confliction with the above. Okay, let's run this. Enter a number. Let me put 4 also. And then now you can see we have 4. So what does this code really means? All right, let's explain. Return x. Okay, what is x? X is 4, the value you imputed. All right, then plus sum x minus 1. Now look at this. The first time x was equal to 4, so 4 is written in the memory. We have 4 here. Okay, then when after the 4, we have a plus sign, so we have a plus sign here. Okay, now sum x minus 1. So what is x minus 1? Of course, it's 4 minus 1, which is 3. Okay, and then now a condition is given here. Is x equals to 1? Because that's the meaning. If x is equal to 1, return 1. Otherwise, is not equal to 1. Reduce whatever value that was given until it gets to 1. So is x equals to 1? No. What is x3? So what do? You have to subtract again. There's sum here. You call the function itself again. So it's going to check again if it is less than 1. No. Or equals to 1. No. So it's going to subtract that 3 minus 1. So the next thing you have here is plus 2. But yet still is not equal to 1. Okay. So it will subtract again. And then we have plus 1 because 2 minus 1 is 1. You got 1. And now it is equal to 1. So it will return the result, which will give you 4 plus 3, 7, plus 2, 9, plus 1, 10. Okay. If assuming this place was 2, all right, if here was 2, you would realize that it will stop at 9 because it will add 4 plus 3 plus 2, and of course it's equal to 2, so it will have to return. If I run this code, you got to see 9. Okay, let's take this one off. Let me comment this. That's why you have that error. Okay, so I had 4, enter. Now we have 9 because it stops at 2. So whatever value you use here will be a determinant on the output. Okay, so let's return back to 1 here and then try to run that again. Okay, so if I enter 4 now and run, you got to see 10. I believe that is understood how recursion works. All right. So having known that, let's kickstart it to the task ahead of us and see how to explain some context. Let me take this off. Okay, so the first task here says write a function that prints a string followed by a new line. I think we've done this. Yes, we've done this. So let's go to the next one. Write a function that prints a string in reverse. We've done that already. Okay. Write a function that returns the length of a string. Okay. That returns the length of a string. Let's have our main.h file, and then let's have another file called length.c. All right. So in my main.h, let's have hash include stdio h. My main, I'm gonna take this off and then use main.h. Okay, so let's see the prototype. Integer, string length, recursion, and then char s. All right, so I'm gonna use mine to be hash include main.h integer length. Let me call it that way, and then integer, or not integer, we got char pointed to a character. All right. So the first thing that comes to your mind is, how do we count? What's the normal way you count the length of a string? Of course, you need to declare a variable, okay, that you count the number of times a character exists in a string. So the same thing is applicable here. You have to define integer. Let me call it count, cnt. Let me just use cnt for count. Okay. So what would the count do if the first thing is a user may choose to pass an empty string? So you have to take note of that. So if ch is not equal to null, if ch is not equal to null, that means if it is not empty, that is when you will do something. Okay. But if actually was empty, then you need to define some conditions depending on what was given to you in the task. I'm not here to solve tasks. I'm just here to give a guideline. Okay, so if actually is not empty, what you need to do first is to start counting cnt plus plus. All right, then you have to call it recursively that cnt return cnt plus the length of ch plus 1. Here you can return 0. Okay, so let's go to our main function and then call the length. Let's have a character here, name, and then let me say thank you for subscribing to my channel. Okay, so let's print printf, and then I want to print a numeric value. Then I'm gonna pass the length and then pass the name in here. All right, we have an issue here, implicit declaration of function. All right, that means we don't have a prototype in the main.h. So I'm gonna copy this to my main.h. Okay, I think that settles that issue. Okay, so let's run this and see what happens. Okay, we got 0. So where could the issue come from? Why are we having 0? Because we have here T1, 2, 3, 4, 5, 6, 7, 8, 9. 9. You're supposed to have 9 printed. So that means our problem is from the length.c we created. So let's go to the length and see how to correct that. Okay, I think it's returning 0 here. So let's return cnt. That means after counting, return the value you've counted for us. Okay, so let's run that again. We're having some garbage value here. So what could be the issue? Now, this is an important aspect of recursion and some other aspects of programs. It is very, very essential for you to initialize your integer value to 0, especially when you're dealing with this kind of context. Because if you don't, the program does not actually know where the count starts from. So hence, it's just incrementing count without knowing the initial value of count. So it is essential that you initialize your count to be 0. Now, if I should run this program now, I'm very sure I'm going to have 9. Okay, you can see we have 9. So that's because it was taking some garbage values in the memory and printed what we saw there. If I come to my main.c and then probably add something here, thank you for subscribing to my channel, all right, and run this, it's supposed to give us okay, 39. If you count these values, this character, it's supposed to give us 39 also. So let's remove this. Probably we had nothing, we had a null value, and run. What will happen? We have 0. All right, that's because we initialize our count to be 0 when nothing is there. So you can actually write a program that checks for it. If nothing is printed, it can write null, it can write no value, you can write anything you like, and it depends on what you want to do. That's it about the recursion for length. Okay, the next one here is factorial. Okay, write a function that returns the factorial of a given number. Now, if n is lower than 0, the function should return -1, indicate an error. Factorial of 0 is 1, and then factorial of 1 to whatever number you want to decide to use. Okay, let me try to give you an insight, but I'm not going to solve that issue. Factorial of c. Okay, it's gonna be numeric, so I'm gonna use integer. Let me call it factorial, just fact, and I'm gonna need just one number, so integer integer f, that stands for factorial. Okay, now if you look at this factorial, it's similar to the first or the second example I gave when we were trying to add numbers 1, 2, 3, 4, 5 that gave us 10, 15 respectively. All right, but the only difference is that factorial is actually a product. The other one was addition. All right, so the first thing you got to do is, if the parameters that was given, if f is less than 1 or less than 0 actually, then what happens? Return -1. I think that was what was given to you. Then else if maybe your f is equal to 0, of course factorial of 0 is 1, so return 1. All right, then else if your f is greater than 1 or equal to 1, actually, if it is equal to 1. Now the factorial of 0 and 1 is 1. The two are the same thing, so I can simply add here if factorial of f equal to 0 or f is actually equal to 1, if any of that two return 1. Otherwise is greater than 1, then you have to do the recursion. So what will you do? You have to return f multiplied by the function factorial into bracket f -1. Exactly what we did the other time. So it's the same thing, and then that's all. Return 0. Right, so let's go to our main and then try to call that. Let's have let's take this one off, and then integer, let me say my n equal to factorial of 4. I'm gonna call it a C for the factorial, and then I'm gonna pass the n as number that I've given. Okay, we still need to add this to our prototype. So let's get this, copy this to the main.h. All right, so let's run this and see what happens. We got 24. So let's see factorial of 2. It's supposed to be 2. We got 2. So let's see 3. It's supposed to be 3 times 2, which is 6. Oh, sorry. Okay. So let's see 4. 4 times 3 is 16 times 2. It's 24. So let's see 4. We got 24. So let's see what if you have something like minus 9 or 8. Let's run that. Supposed to have minus 1 as a result. So we have minus 1. That is very correct. Okay. So I think that's how to write that very program. I was not supposed to write everything, but I just had to. But subsequent programs, I'll try to leave some things out so they can sort it out yourself. That's going to help you grow in the program. All right. Okay. The next one here says write a function that returns the value of x raised to the power of y. Okay, x raised to the power of y, and this time around we are using 2 parameters. So let me just get this. All right, I will try to explain what this code does and how it works, but I'm not going to write for this function less than 0, less than 1, and the rest. Try to inculcate that to your own program. Okay, so let me put that in my main.h. I'm going to change this to power alone. All right, so let's get this and write a function for that. Let me call it power.c. Okay, first of all, how does this code work, or how will this code work? What's the expectation of this code? All right, if you look at this project, it is stated here that the similar library power is used. So let's see what this power does. All right, let me just use Google and said man POW in C. All right, so look at this. Let's look at the man page. It says here in the description, this function shall compute the value of x raised to the power y. Example, x star star, that's asterisk asterisk y. If x is negative, the application shall ensure that y is an integer value. Let's look at that and see what that means. Okay, so let me go to my main and try to utilize that first before we go into the coding part of it. So let me just comment this off. Assuming I have integer n, okay, then I say n, or let me say equal to 2, all right, power into n, which is 2 comma 2. Okay, this is supposed to be found under the math library, so I'll have to call the math library, include maths.h. Then let's print that power n comma 2. So let's remove this from here. Let's just take this off and print it directly. Okay. All right. The format specifier is if. So let's run this. Now you can see that 2 raised to the power 2 is 4. And then if I change this to, let's say 4, it's supposed to give me 16. You can see we have 16. I can use 0.0 here to remove that decimal point. Okay, we have 16 here. All right, so we are asked to write a similar function to do the same thing. Okay, So what happens here is that at every time when you pass 4, it is going to multiply the value that was given, which is 2, in 4 places. So it's a very simple strategy to do. It's very simple strategy to do. What you simply do is to, of course, your if will come to play. If, let's say, because we are dealing with the x is the major base, is the base value, while y is the exponential value. So if your x is equal to 1, of course, you don't need to do anything with that. If it is 1, of course, you have to return 1, all right? But else if y, not x, if y, that's the exponential value. If y is equal to 1, all right, you have to return x the way it is. Maybe x was 3 and y is 1. Of course, it's going to return 3, all right? But whereas the value of y is above 1, that's else if the value of y is greater than 1, then you need to do something. What will you do? You need to return x multiplied by the power, okay, of x, while the y will do what? Will decrement. Okay, so this means that if y was approximately, let's say 3, okay, the first time y is going to be 3, while x still remains the value you gave, 2. So that 2 will multiply by 2 again. Now y will decrement to 2. It have to multiply until it decrements to the last value, which is 1. So after this, let me just let's return x. On the main.c, instead of using this, I'm going to use my own function which I have declared, and I used my declaration was integer, so that's why I'm changing it to integer. Let's run this program. Okay, we got 16 here. So let's change this to let's say 5. It's supposed to have 32. We got 32. So let's change it to 1. Okay, have 2. Okay, now what if you change it to a negative value? Let's say -3, -4, -1, or minus anything. What will happen to the program? Find out and then leave a comment in the comment section. If there's anything you need to correct in that code, of course you need to correct something, please do so and write the solution in the comment section. Thank you. Okay, so that's about that very task. Now let's go to the next task. Here, to write a function that returns the natural square root of numbers, and then the prototype is given here. If n does not have a natural square root, the function should return -1. Then the library provides the same function with sqrt. So let's see what this function actually does. My main.c, let me just use here to sqrt. Then let's have a number here. Let's call it 25. And let me run. I think it's supposed to be float. All right. So on running this, you can see we have 5. Of course, square root of 25 is 5. So you're asked to write this same code. Okay. So let's try to do that. First, let's see how to implement that using a for loop. Let me take off this smart.h. So you're not going to be. All right. So for you to do that, you need to declare a variable. Let's just declare a variable called let's say I. Okay. But at the same time, I'm going to declare another variable. Let's say n. And the n is the variable that you will pass the value to. Let's say that printf, all right, enter value, then scanf d, and then pass it to address. Right now, for I equal to 0, I less than n, all right, then I plus plus. Now in here, we're going to say if I multiplied by I is equal to n, print f the value of I. Okay, let's run this and see what happens. So let me add hash tab. Let's run it again. Now you're asked to enter a value. Let's say I enter 4 because I know 4 is the square root of 4 is. Now I hit enter, you have to. Okay. So let me run again and probably enter 25. If I hit enter, 5 because the square root of 25 is 5. All right. So let me run again and put a value that has no square. Let's say I have 3. Enter. See, 3 has no result because it's not a perfect square. All right. So now this is using for loop. But how can we use recursion write this same program? Okay. First and foremost, if you look at your prototype, you realize that you have only one parameters to be passed in the argument. Okay. But if you look at what you've written here, you actually need 2 parameters. You need the I to be incrementing while checking the value of n. Okay. So in this aspect, your prototype should be argument. All right. So let's see how to implement that first. Let's see how to implement. And the first thing you will do is to declare your prototype. Let me write a new prototype. I'm going to call it quiz.c. So in here, I'm going to have integer, let's say sqrt1, right? Then I'm going to pass 2 arguments, integer I, all right? And then integer n, where the I is the value that you'll be taking. Ensure when you multiply it together, it's going to have n. So in here, I'm going to say, first of all, if the value of n is equal to 1, of course, the square root of 1 is 1. So you have to return 1. Then else if the value of I multiplied by I, exactly what we did the other time, is equal to n, then you have to return I. All right. But if the first value, when you are iterating, if for the first time, let's say 0 times 0, of course, it's going to be 0, which is not equal to n, the next thing you will do is to return the function sqrt1, then you increment the I. That's going to be I plus 1, while still checking for the value n. Okay? Let's terminate this very part. All right. So with this, you can actually check for a perfect square depending on the number provided. But the issue is that we are going to be passing parameters to this argument, which is not supposed to be so. We're going to treat that now, but let's start with this. Let's copy this, our main.h. Okay. So let's try to run the program and see what happens. In here, I'm going to take this off. Okay. And then I will print f %d. Then I will call the function name sqr1 into, now the first value will be the start point of your I. I can call it 1, okay, comma, and then you're going to be checking for if I times I give me, let's say, 5. Of course, we are expecting 5 to be the answer. Okay, so the first term is going to be 1 times 1 according to what you wrote here. Squares. 1 times 1, is it equals to n, of course, which is 5? No. If it's not equal to 5, it will add 1 to the I. That's line 9. Square root of I, it will call back the function, then add 1 to the I, it becomes 2. So 2 times 2, is it equals to n? If it is no, it will add again. It will continue until it gets to the last value. But if along the line I times I is equals to n, it will return the value of I and print it on the screen. Okay, so let's run this program and see what happens. Let's terminate this and then run the program. Enter a value. Okay, that's because of this. Let me just take this off. Let's take that off and then run again. Okay, so you can see we have 5 as an answer. Okay, so let me use 4. Supposed to give us 2 as an answer. Okay, we got 2. So let me use something that's not a perfect square. Let's say 5. Supposed to print nothing. Okay, so the program is correct. But now the issue is, how are you going to solve this problem? So because a user is supposed to have just one value and not 2 values at the same time. So look at what we're going to do now, right? Let's create a new file. Let me call it underscore srt.c. Okay, then we're going to write the function that you will use. And this will be the major function you'll be using to call this squares we created. So let's call it integer, and then let's say underscore sqrt, the square root of any number you pass, integer n. Or let me use let's say number. Okay, now, all right. So in here, what I'm simply going to do is to return the function we created in this squares.c, which is the value of I, and then whatever value will be passed as an n value. So I'm going to return the function that we created, which was sqrt1, open bracket. Now the first value, which is I, I'm going to leave it at 1 because it's going to be ending from value 1, then comma num. All right. So with this, you're just going to be passing the value for number alone. Thereby, your program will have to call the other program to do the execution for you. So now, if I want to run a program in main.c, I'm going to use sqrt underscore sqrt square root of, then I'm going to pass the number directly. Let's say 4. Implicit declaration of function. That's because we have not added our prototype to main.h. So let's do that quickly. Okay, let's go back to the main. Okay, it's now fine. So if you run this program, you're supposed to have 2 as an answer. All right, it's fine. We got 2. So let's try to use 25, 25 and run the program. So we got 5 here. Now let's say I use something like 5. Okay, it's supposed to print nothing. Okay, we got nothing printed. But if you look at the program, it's not stopping. That means it's still running. That's because we've not written a code to checkmate if the value doesn't have a perfect square. All right. If you look at what was given here, there's a condition for you to write. If n does not have a natural square root, the function should return -1. So I'm sure you know how to manipulate this in your. Okay, I was just here to give you a guideline of how to run that code. Okay. All right. So that's that about this very task. The next one here is write a function that returns 1 if the input integer is a prime number, otherwise return 0. Okay. First, what is a prime number? A prime number is a number that is divisible only by itself and 1. Okay. So now, what comes to your mind is, how can I write a function that checks if any other code or if any other value is not divisible by 1? All right. I'm going to use for loop, write the program for you, then use that idea, generate the code in function. All right. Let's straight to that. I'm going to create a new file called prime.c integer prime underscore number n. Let me add this to my prototype. H. Okay. So now known that prime numbers is only a number that is divisible by itself and 1. Okay. So we are gonna have something like a loop. All right. Because I'm gonna use a loop to do this, while you're gonna use recursion to do yours. Now let's say integer I. I'm gonna use I for the loop. Then let me use prime for the result. Okay, so what happens here is that for I equal to, now I can't use 0 for the start value, and I can't use 1. Why? A prime number is divisible by itself and 1. So hence I can't start with 1, check if it is divisible, but rather I'm gonna start with 2, okay? And then I'm gonna say I less than n. I'm not gonna say less than or equals to, because it's not gonna check for itself, but rather it's gonna check the number before the n, which is the value input. Then I is gonna increment. Okay. In here, we're gonna use an if statement to check if the value input is divisible by I. So if n modulus I equal to 0, what does that mean? Let's assume your n was 4, right? Now the first time n modulus it equals to 0, yes, that means 4 is not a prime number. Okay. But what if I use 3? The first time it's going to check 3 modulus 2. Is it equals to 0? No. That means 3 is a prime number. Now let's check 5. 5 modulus 2. For the first time I use 2. Is it equal to 0? No. It checks again. Is it equal to 0 for the second time? That's 5 modulus 3. Is it equal to 0? No. It checks for the next time. Is it equals to, that's 5 modulus 4. Is it equal to 0? No. That means it's not, or that means it's a prime number actually. So at any time you check for n modulus 1, if it is equal to 0, then prime, the value here, variable we created here, will be equal to 0. Okay. But you have to initialize your prime to be equal to, let's say, 1. All right. So if at any time you check and then prime is equal to 0, break it out. Don't check again. All right. What does that mean? Let's say, you have a value like 10. Now 2 is 2. 10 modulus 2 will give me 0. All right. Then 10 modulus 5 will also give me 0. Now there is no point checking again when once the first value, which is has a remainder of 0. There's no point checking again. Just break out of the loop, because you know that it is not a prime number. All right. So I think with this you can write the function. Let's see how to utilize that. So let me go to my main dot, then call the prime number. So here we'll have prime number right here. Then I pass 5. Okay. I think 5 is the prime number. So let's run and see. Okay, we got some garbage value here. Let's check our prime again. .c. Okay, we did not return. We need to return prime. All right. return prime. Okay, let's try that again. Okay, we got 1 because it's not, it's a prime number actually. All right, so we got 1. But if it's not a prime number, let's say it's like you had 4. Let me go to my main.c. Had 4, of course, 4 is not a prime number, so we're expecting 0 as a return value. So we got 0 here. So let's look at our task. It says write a function that returns 1 if the integer is a prime number. But if it's not a prime number, return 0. So we've been able to actually do that here. Because if we have something like 7, the prime number, right? So it's supposed to return 1. Okay, we got 1 here. So if we have something like 10, of course 10 is not a prime number. So it's supposed to return 0. That's 0 here. So this is correct. Now try to, just like what I've been doing all this while, try to implement this using recursion. All right, and then leave the result, leave your code in my comment section. I want to see how you do this. Different code, different solutions from different people. I'll be happy to see you try something good right here. For now, I got to say bye.